Okay, so I have two exponential equations to solve, and they both require that you use the one-to-one property of logarithms. What that property says is if you can get the bases the same in the exponential, then you can set the exponents equal to each other. So the basic property is if a to the x equals a to the y, then x has to equal y. So from here, in this first example, we have a base of 3 and a base of 81. I can rewrite the number 81 as 3 to a power. That would be 3 to the 4th power, and this one already has a base of 3. So if the bases are the same, I can set the exponents equal to each other. And then solve for x. So add 9 to both sides of the equation, divide by 2, and that's your answer. For the second question, it's a little trickier because if you look at the number 8 and you think, well, okay, well that base is 8 and I need to write 16 as a base of 8, you can't, because 8 squared is 64, not 16. So we have to think back further. What base do they have in common? Well, in this problem, I can think of 2 as a common base to each of them. So 2 to the 3rd is another name for 8, and it's still raised to the x power out here. 2 to the 4th is another name for 16, but it still has this power of 2x minus 1. Using laws of exponents, when you raise a power to a power, you multiply the powers together. So this is 2 to the 3x equals 2, and then distribute the 4. So you have 8x minus 4. Now that the bases are the same, you can sort of disregard them. You're not dividing them off, you're just ignoring them for the moment and setting the powers equal to each other. Again, that's the one-to-one property of exponents. So if I set the exponents equal to each other, I can then solve for x. So subtract 8x from both sides, collect your variable on one side of the equation, things that don't have a variable on the other, and then divide by -5. So this is going to reduce to x equals 4/5. Okay. Another example, kind of along that same line, is this one, e to the 2x minus 2 equals 1 over e. I can see that they have the same base, it appears, but this e is down in the denominator. So I can rewrite 1 over e using laws of exponents as e to the -1 power. Remember, if it's e to the 1 down here and you move it up, it becomes e to the -1. And now that the bases are the same and they're both in the numerator, I can go ahead and set the powers equal to each other. So 2x minus 2 equals -1. Add 2 to both sides, and then divide by 2. And that would be your answer.